Hey, good morning, ladies and gentlemen. And today we're going to go ahead and do a quick video tutorial on how to balance chemical equations. So the first thing I'm going to do is I'm going to go ahead and draw my line right here to separate my reactants and products. And so I'm going to go ahead and start off by listing my reactants. So that's phosphorus right there. And I can tell that we have 4 phosphorus on the reactant side and we have 2 oxygen on the reactant side. The way I can tell is because I'm looking at these subscripts right here. Then let's go to our product side. On our product side, we have 2 phosphorus right here, and then we have 3 oxygen right here. So if you can take a look, you notice that the number of phosphorus on each side is unbalanced because I have 4 phosphorus on the left, only 2 on the right. Then my oxygen, I only have 2 oxygens on my reactant side and 3 oxygens on my product side. So as a rule of thumb, I always say start our coefficients off with the number 2. So one thing to know is that you don't always have to put a number 2 in front of every element. So that doesn't mean you're going to put a 2 all the way across. That means that you're going to actually look at the number of elements you have each side, and then if you need to add a subscript, you start off with the number 2. So for example, I have 4 phosphorus on the left, I only have 2 on the right. If I want them to be balanced, that means I want to have 4 phosphorus on the right. So what can I do? Remember, when you put a coefficient in the front, it multiplies and distributes to both elements. So let's go ahead and take a look at it and see what it looks like. So let me go ahead and put my 2 right here. This 2 gets distributed to phosphorus and it goes to oxygen. So instead of having 2 phosphorus, I have 4 phosphorus now. And then instead of having 3 oxygen, remember, when it gets distributed, it multiplies, it does not add. So this is not going to be 2 plus 3 equals 5. This is going to be 2 times 3, which is going to give us 6. So now if you take a look, our phosphorus are now balanced, but our oxygens are not. We have 2 oxygens on the left, we have 6 oxygen on the right, but this is pretty simple. All I have to do is ask myself, what do I multiply 2 times to get 6? And this should be pretty easy. 2 times 3 is going to give us 6. Remember, these two multiply, they do not add. Then someone might say, well, coach, what do we put in front of this phosphorus? Well, we can just put a 1 right here because 1 times 4 is still going to give us 4. So now take a look. We have 4 phosphorus on each side and we have 6 oxygen on each side. So now this chemical equation is officially balanced. All right, so let's go and take a look at another problem. So in this problem, we're going to do the same thing. We'll go ahead and draw a line down the middle to separate our reactants and products. So now we have 1 sodium on the left, we have 1 fluorine on the left, and we have 2 bromine on the left on our reactant side. So now we're going to go ahead and set up our product side, and we have 1 sodium on our product side. We have 2 fluorine on our product side, and then we have only 1 bromine on our product side. So if you could tell, our sodiums and our sodium is balanced, but our fluorine and bromine are not balanced. So I have 2 fluorine on the product side. I only have 1 fluorine on my reactant side over here on the left. So the first thing I would want to do is I would want to add a 2 in front of the fluorine. Now, the reason why I did this is because if I have 2 fluorine on the right, then I would want to have 2 fluorine on the left. So I put a 2 right here. And remember, this 2 gets distributed to sodium and to fluorine. So now I have 2 sodium and now I have 2 fluorine on my reactant side on the left. And then I have my 2 bromine right here. But now if I look at it, I only have 1 sodium here, but I have 2 on my reactant side. So common sense tells me that if I have 2 on the left, I would want to have 2 on the right. So guess what I'm going to do? I'm going to go ahead and put a 2 right here. That 2 gets distributed to sodium and bromine. So I cross that out. I have 2 sodium right here, and then I have 2 bromine. So let's go ahead and take a look. Are our sodiums balanced on each side? Yes, they are. What about a fluorine? 2 and 2. And then what about our bromine? 2 and 2. And what would we put in front of fluorine? Well, we'll just put a 1 right here because 1 times 2 gives us 2. So our coefficients are 2, 1, 2, 1, and now we are balanced. All right, we're back with one more equation. And one thing I love about balancing chemical equations is that it really reveals to you who you are. It lets you know if you're a winner or a quitter. And what I mean by that is that I see a lot of people quit when they try to put a 2 in front of everything. And then when the 2 doesn't work, they just sit there, well, I guess that's it. So it kind of, lets me know, all right, this person is going to try one thing. And if it don't work, they just quit. So I enjoy balanced chemical equations because it literally reveals, who are you? Are you a person that keeps going and striving? Or are you a person that quits? So for me, I like it because it's a challenge, because I like to keep going until I get things right. But some people, hey, you ain't got that. If you ain't got the winner's blood in your heart, I get it. I get it. So if you quit on everything that's easy, man, God, dog, when you get in the real world, boy, that thing gonna suck for you. So let's go ahead and take a look at this problem right here, and let's go ahead and separate the winners from the quitters, or the winners from the losers. So if you notice, I have 2 carbon on the left. On my reactant side, I have 6 hydrogen on my reactant side, and then I have 2 oxygen on my reactant side. On my product side, I have 1 carbon, and then I have 2 hydrogen. But if you look right here, I have 2 oxygen right here and 1 oxygen right here. So I actually have 3 oxygen on this side. And I can already tell by looking at this problem, this is not one of the type problems you just put a 2 in front of and it just gets solved. So this is going to take some time. So the first thing I'm going to look at, I'm like, okay, so I got a 2 right here. I only got 1 carbon right here. So let me throw this 2 right here. So I put that there. Boom, boom. So now, instead of having 2 carbon over here, instead of having 1 carbon, I have 2 carbon now. And then instead of having 2 oxygen, I now have, instead of having 2 oxygen right here, I now have 4 oxygen right here. But then I have another one, so that's going to give me 5 oxygen. That ain't looking too good right there. And then now let's go ahead and take a look at this. I have 6 hydrogen on the left-hand side, and I have 2 hydrogen on the right-hand side. So I said, okay, well, let me try to put a 3 right here. So I put a 3 right here. It gets distributed to hydrogen and oxygen, and I cross this out. This ends up being 6. And then now I have 4 oxygen right here, and then I have 3 oxygen right here. So now I end up with 7 oxygen. So something about that just ain't right. So that lets me know I got to go back to the drawing board, because this is not working. The things that are balanced, I got my carbons balanced, I got my hydrogen balanced, but my oxygen is not balanced. So that lets me know that these coefficients are not the ones that go in front. So let me try something else. Let me go up to the next thing. So let's go ahead and erase this stuff out. And so this is what I mean by your winners and your quitters. By this time, if a quitter has got to this point and they see that this first part didn't work, they just go ahead and quit. They give up. But I trust y'all got a lot of winners in your class, so you're going to keep going. So the next thing I'm going to look at, I'm going to say, okay, all right, so let me take a look at this, because these didn't work the first time. Let me go ahead and try let's see. Let's go ahead and look at this. So if this got me to 7 right here, and this is still 2, what is the least common multiple between 2 and 7? And so 2, 4, 6, 8, 10, 12, 14, and then 7 times 2, 14. So I'm going to put a 7 right here. Now, do I know that this is going to work? No, I do not. So I'm going to try this, but I'm still working. I'm still grinding, because I don't quit on stuff. So 2 times 7, that's going to give me 14 right here. All right, so I have 14 on this side. So how do I get to 14 on this side? So I'm going to put a 4 right here, and then I'm going to put a 6 right here, and I'm going to explain why. I'm going to put a 4 right here. So this is going to give me 4 carbon on the right hand side. This is going to give me 8 oxygen right here. So then let's go ahead and distribute these. Now I'm going to end up with 12 hydrogen on my right hand side, on my product side. Remember, y'all, I'm just going through, I'm still trying things out, making sure, seeing if it works. If this doesn't work, I'm going to keep going until I get it right. And so I have 4 times 2, that give me 8 oxygen right here, but then I have another 6 oxygen right here. So 8 plus 6, that's going to give me 14 oxygen on this side. So I'm gonna have 14 oxygen on this side. So I have my oxygens correct. So now on this side, I have 12 hydrogen on this side, I only have 6 on this side. So 6 times what gives me 12? I'm gonna put a 2 right here. Let's see what we got. I put a 2 right here. All right, so let's see. All right, 2 times 2, that's gonna give me 4. Oh man, well look at that. 2 times 6, that's gonna give me 12. Boy, look at that right there. Look at that. Let me calm down. So ladies and gentlemen, we have 4 carbon on each side. We have 12 hydrogen on each side. And we got 14 oxygen on each side. And ladies and gentlemen, the biggest difference with solving this chemical equation is that I just didn't quit on the problem. I just kept going until I got it right. So ladies and gentlemen, that's it. The biggest thing about solving chemical equations or balancing chemical equations is that you keep going until you get it right. Don't quit. Don't give up on the problem. If you quit, you will never get it right. I promise you. But if you keep going, it's a strong possibility you will make it, you will get it right. And that's all about life right there, ladies and gentlemen. So balancing chemical equations and then balancing out life. If you quit, you will always fail. Keep going, you're going to win. Y'all take it easy. Peace.